Hey guys, this is Eva from the Black Squad again. It's been a while since I last uploaded my video, and sorry, I have been really busy with other stuff, and I also have been working hard and spending a lot of time thinking of how should I present this case study to you. So I hope you gain something from this chapter. So after learning Babel's compilation process, AST and API, we are ready to do something more interesting. And let's start with a simple feature first. So here's the requirement description. We often log to aid debugging, but sometimes we don't know where exactly to log. Babel can automatically insert the parameters of the file name, line, and column number into the API such as console log, which points to the position of the code. So let's convert this code into this. So let's move on to the analysis. We use AST-Explorer.net to view the AST of the console log. The AST of a function call expression is call expression. So what we need to do now is to automatically insert some parameters into APIs such as console log and console info when traversing the AST. That is to modify the AST of call expression through the visitor. And the call expression node has two properties, callee and arguments, correspond to the function name and parameters of the call respectively. So we can insert an AST node into the array of arguments when callee is console.something. And now I'll move on to the code implementation. Okay, so now we have come to the code implementation part, and I'll be showing you the whole process and the idea behind it, so you could understand better. Try to follow me closely on this, step by step. So the compilation process includes parse, transform, and generate. Let's set up the overall framework first. So firstly, let's create a folder named chapter 5. We use npm to initialize the project and create an index.js file. And now we could start writing the code. Before this, we have to install the corresponding Babel modules before we could use them. This would include Babel parser, Babel traverse, and Babel generator. So now, let's say the source code we want to process is console log 1. We need to use parser to convert the source code to AST. And we'll leave the source type as unambiguous. We'll be using the traverse way to adjust the call expression of the AST. And for now, let's leave the call expression part empty. Lastly, we will convert the changed AST into code and source map. Print the code and run in node index.js. The parser needs to know whether the code is in the ES module specification. It needs to specify the source tag its module or script through the parser options. We can just set it to unambiguous and let Babel set it according to whether the content contains import or export. After setting up the framework, let's first design the code to be converted. And now, let's change the source code console.log1 to something more complicated. Besides console.log1, we define a function and a class as well. The JSX syntax is used here, so the parser needs to use the JSX plugin. And so let's code according to the analysis. When we started, we left the core expression empty, and now it's time to modify the ASC of the core expression. If the API is console.something, then we insert row and column number in arguments. When the calling part is member expression and console log, console info, console error, console debug. Insert the file name, row and column number in the parameter, and we can get row and column number from the public property block of ASC. Then try running it. The result is as expected. But now the condition of if statement is too long. You can simplify it like this. Generate callis ASD as a string, and then let the string be the condition of the if statement. In fact, we can use the generator module to simplify this. Actually, you don't have to call generate. Parse has an API named toString, which generate AST as code output. So to simplify this, the above code can be changed to then try running again. As you can see, the result is as expected. And we are done with the first part. Okay, so let's move back to our PowerPoint now. I hope you follow me till here. If not, please watch the first part again before we move on to the more challenging part, which is to change the requirement. So, however, generating on the same line would affect the display of the original parameters. So, we want to change to the method of generating before the console something node. So before that, we are changing console log1 into this, and now we are changing the requirement to this. Okay, so move on to the analysis. The change in this requirement is just from inserting a parameter to inserting a console log AST before the current console something AST. The overall process is still the same. However, there are 2 points to take note here. First, the console code in JSX cannot simply insert a node in front. We need to replace the whole with an array expression because JSX only supports writing a single expression. So means we have to change from this into this. As we know, inside the curly bracket can only be expression. This AST is called JSX expression container, the expression container. And secondly, after replacing the old node with the new node, the inserted node is also console log, which is also be processed. However, it is unnecessary. So the processing of the newly generated node should be skipped. And next, we'll move on to the code implementation. The AST needs to be inserted here, and the API of path insert before will be used. And replacing the entire AST is also required, and the path replaced with API will be used. Then you need to judge whether the node to be replaced is under JSX element. So use the API of find parents to find whether there is a JSX element node on the path. Also, after replacement, call path skip to skip the traversal of the new node. Just like this. To skip the processing of the new node, you need to add a mark to the node. So if there is this mark, then skip it. And the overall code is as follows. Take a minute to read this or take a screenshot. Pause it if you need. So at this point, the need to insert file names, line, and column numbers in console log is completed. So now let's try to transform it into a Babel plugin. So if you want to reuse the above conversion function, you should encapsulate it into a plugin. And Babel supports the transform plugin, which looks like this. The form of the Babel plugin is that the function returns an object and the object has a visitor property. The first parameter of the function can get the API such as types and template. And when it is used as a plugin, you don't need to call parse, traverse, and generate by yourself. These are general processes and Babel will do it. We only need to provide a visitor function and complete the conversion function in this function. That's all. The second parameter state of the function can get the configuration information of the plugin, options, etc. For example, we can get file name through the state file name. The above code can easily be transformed into a plugin, which looks like this. Then you compile the code through the transform scene method of Babel call and bring in the above plugin like this. So in this way, we have successfully transformed the code that called parse, traverse, and generate into a Babel plugin. We only need to provide a conversion function, which will be automatically called during the traversal process. So I'll move on to the summary next. In this session, we practice Babel's API through a practical case study of inserting parameters in console.something. So first, we organize the compilation process through Babel parser, Babel traverse, and Babel generator. Create AST through Babel types and operate AST through various API of path. And later, the requirement was changed to the way of inserting console something in front. We use the Babel template module to insert and replace the AST through path replace with and path insert before. It is necessary to use path find parents to determine whether the parent element of the AST contains an AST of type JSX element. The AST of child node is to be traversed with path skip, and the new AST needs to be marked and skip the processing of newly generated nodes. After that, we transform it into a Babel plugin, which is a function returns an object. The first parameter of the function can get the APIs of various Babel commonly used modules, such as types and templates. The plugin does not need to call APIs, such as parse, traverse, and generate, and only needs to provide visitor functions. And lastly, we use this plugin through Babel calls API. We have done some practice on the compilation process of AST API that we learned in the last 4 chapters, and hope this chapter helps you to understand better. I will place the code in the comment sections, and it's recommended for you to git clone and run it. So that's all for chapter 5 on Babel in action, and I'll see you guys in the next video on history of JS puzzle. So if you have any questions, feel free to comment in the box below, and also you can contact us directly at supertripled41@gmail.com. Make sure you click on the subscribe button and stay tuned for chapter 6 of Babel. See you there!